Hi, let's get started with our new section. In this video, I want to introduce to you customer lifetime value. So in this section, we are going to focus on the second use case of predictive analytics in marketing, the customer lifetime value. So in marketing, it is always a challenge to budget for marketing campaigns. We do not want to spend too much and result on a negative ROI. However, we also do not want to spend too little and have no visual impact or outcome. When determining the budget for a marketing strategy, it is essential to know that the expected return will be from running a given marketing campaign. Understand what the customer lifetime value, which is the CLV, is for individual customers can help marketers justify their marketing budget as well as the target potential high value customer. So in this section, we are going to discuss in more detail the concept and the advantage of calculating the CLV, as well as how to build a predictive machine learning model to predict the expected CLV for the individual customers in Python. So in marketing, the customer lifetime value, which is the CLV, is one of the key metrics to have and monitor. The CLV measures the customer total worth to the business over the course of their lifetime relationship with the company. This metric is essential. It is especially important to keep track of for acquiring new customers. It is generally more expensive to acquire new customers than to keep existing customers. So knowing the lifetime value and the cost associated with acquiring new customer is essential in order to build marketing strategies with a positive ROI. So for example, if the average CLV of the customer is $100 and it only costs $10 to acquire new customer, then your business will be generating more value as you acquire new customers. However, if it costs $150 to acquire a new customer and to average CLV of your customer is still $100, then you will be losing money for each acquisition. Simply put, if your marketing spend for new customer acquisition exists, the CLV, you will be losing money for each acquisition, and it's better to just work with the existing customers. So there are multiple ways to calculate CLV. So one way is to find the customer average purchase amount, purchase frequency, and the lifetime spend, and do a simple calculation to get the CLV. For example, think of a hypothetical case where a customer average purchase amount is $100 and he or she makes purchase 5 times every month on average. Then this customer average value per month is $500, which is simply multiplying the average purchase amount with the average purchase frequency. Now we need to know this customer lifetime spend. One way to estimate a customer lifetime spend is to look at the average monthly churn rate, which is the percentage customer leaving and terminating the relationship with your business. You can estimate a customer lifetime spend by dividing 1 by the churn rate, assuming 5% of the churn rate in our hypothetical case. The estimated customer lifespan is 20 years. Given the customer average value per month of $500 and the lifetime span of 20 years, the CLV of this customer turns out to be $120,000. So the final amount is calculated by multiplying $500 and the average value per month by 12 months and the lifetime span of 20 years. So because we do not typically know the lifespan of customer, we often try to estimate CLV over the course of a certain period. It can be done by estimating a customer 12-month CLV 24-month CLV, or can also be 3-month CLV. Aside from the method we discussed through an example, CLV can also be estimated through the building predictive models. Using a machine learning algorithm and the customer purchase history data, we can build machine learning models that predict customer CLV over the course of a certain period. So in the programming exercise in this section, we are going to learn how to build a regression model that predicts 3-month CLV. Now is the time to talk about evaluating regression model. So we need to use different set of metrics for evaluating regression models from those for classification model evaluations. This is because the prediction output of a regression model takes continuous values, meaning it can take any value and is not restricted to taking from a predefined set of values. So in this section, we are going to discuss four commonly used methodology to evaluate regression model: the mean square errors, median absolute error, which is MAE, R square, and predicted versus actual scatter plot. So as the name suggests, mean square error, which is the MS, measures the average of the square errors, where the errors are the differences between the predicted and the actual values. The equation for the mean square errors is like that. So we have mean square error equal 1 divided by n, and the sum I equal to 1 to n, and then we got yi and y dash I square. So the y values in this equation are the actual value, and the y dash values are the predicted values, because the MS is an average of the square errors. This measure is sensitive to and highly affected by outliers. So the MAE is also known as the mean absolute errors. On the other hand, is less sensitive to outlier and considered more robust, as the median is affected by the outliers or values at the end tails much less than the average. The equation borrowed from the scikit-learn documentation page. So this is a scikit-learn documentation link of the page. Looks at the follow. So mean med, we got the median absolute errors, which is y and y hash equal median y1 minus y hash. As you can see, y1 hash, and we got until yn minus yn hash. So the y values in this equation represent the actual value, and the y hash value represent the predicted values. Another frequently used measure for regression models is R square, is also called as the coefficient of determination. R square measures the goodness of fit. In other words, it measures how well a regression model is fitted to the data. Simply put, R square is the percentage of the explained variability of the target variable by the regression model. So the equation like that. So we got R square equal the explained variation divided by the total variation. So R square typically ranges from 0 to 1. The R square value of 0 means the model does not explain or capture the target variable variability at all, and is not a good fit to the data. On the other hand, the R square value of 1 means that the model captures 100% of the target variable variability and is a perfect fit to the data. The closer to 1 the R square value is, the better the model fit is. So lastly, a scatter plot of the predicted values. Again, the actual value is also used to visualize how closely the model fit. So as an example of this scatter plot look like this one. So we got the out of sample actual versus predicted, and then we got predicted, and then we got the actual. So for a good fit, you will see points in this scatter plot that are close to the diagonal line. If the model's R square is high, the points will be close to the diagonal line. On the other hand, if the model R square is low, the point will be dispersed away from the diagonal line. So in the following programming exercises, we will discuss how to compute and visualize these measures in Python, and we'll use these measures to evaluate our regression model. And that is all in this video, so I hope you enjoy it, and I will see you in the next video.